Hello friends, so today we are going to introduce what we call the binomial distribution. This is an extremely useful distribution. You can solve a lot of problems with it, and you actually don't need a lot of experience in mathematics to be able to solve some really good problems for companies. Usually companies, they hire consultants to do some math for them, and in their mind it has to be sophisticated math, but as you can tell, as you will see, you might feel a little bit of pressure, but after a session or two you're going to feel very comfortable with this distribution. And a lot of companies hire people to do the work that I'm going to show you. Okay, so let's say I just made up this story. So let's say a company produces light bulbs, okay? And they hire you. You'll say, what do I know? Well, in 1 or 2 sessions, you'll be able to play the role of a quality control. You can actually do some really good analysis and get back to the company with your expertise on what do you think. So they hire you as a quality experts, control experts, to give them an idea about their product. So you decided, and by the way, just before I continue, let me just say something about quality control. I can guarantee you that companies can make light bulbs that can last for, 4, 5, 6, 7 years. But they don't. Because if they do make them that last for many years, the customers will be very happy, but the companies are not going to make a lot of money. Okay. Conversely, they can definitely make light bulbs that burn in one day. Okay. So yes, you can make a lot of money because you will constantly sell light bulbs. The problem with that is the customers are not going to be happy. So companies usually, they try to figure out a really a good time frame where they could make money and at the same time keep customers happy. Most light bulbs, obviously it depends on how long you use them in a room, but most of them last somewhere between, I would say, 3 to 6 months, okay? That's just a side note, okay? Now, they hire you. They want your advice on their light bulbs. So what you did, you took a sample of 20. They probably produce 10,000 a day or something. You took a sample of 20. Right now, we don't know how to select the sample. We haven't. In fact, next week, we're going to talk a little bit about how to pick a sample that represents all the light bulbs that they make. But let's say for now, you were able to select a sample of 20, and you're going to test them. Basically, you're going to see whether or not they are defective or non-defective, okay? Of course, you don't want to burn all of them to figure out what the percentages are. You could definitely burn all of them, say, okay, or break all of them. It's okay, this one is defective, this one is not. Oh yeah, 90% are good. Yeah, but it just destroyed all light bulbs. So you're not going to destroy all of them. You're only going to destroy 20 or test. Let me just say test 20. Some people will break them and find out if those strings were attached, and some of them will just literally test them one by one. Okay, so you found out that 4 of them are not good. And also that means 16 of them are good. Now remember that 4 out of 20 is 20%. I picked nice numbers. 20% are defective and 80%, which is 16 of them, are good, right? So that's what you actually found out. But that doesn't tell you everything about all their light bulbs. It only tells you something about the 20 light bulbs. So basically, you want to gather some information based on what you just found. You want to gather some information to give them advice. We may not necessarily get into the real advice, but for now, you really want to report back, okay? So the first thing you did, you took 20, you tested all of them, and you found that 4 were bad and 16 were good. So that means 20% are defective which means 80% are non-defective. Okay? So, as I mentioned before, you should always figure out what X, the letter X, stand for. So I wrote it down. Let X stand for the number of non-defective light bulbs. So if I say X equals 3, it means 3 are good. If I say X equals 20, it means 20 are good. Does that make sense? Okay, because you've got to decide whether you want to pick X to be the defective light bulbs or non-defective light bulbs. I like to choose X to be the good ones, non-defective light bulbs. So because you're an expert, you kind of thought, maybe this random variable follows a binomial distribution. So what does that mean? Any random variable, notice that this is a discrete one, right? It's 1 light bulb, 2 light bulbs, 3 light bulbs, 4 light bulbs. You can't have 1.3 light bulbs. So clearly it is quantitative and discrete, not continuous. For it to follow a binomial distribution, to be of binomial distribution, it has to fulfill 4 requirements. If any random variable fulfills 4 requirements, you can make the claim that X follows a normal binomial distribution. And if that is the case, you can do some really good math with it, okay? It happens that this one follows a binomial distribution. So what are the conditions that you have to test? You must test the conditions before you do any math, okay? Because this gives you the green lights to call it binomial, those 4 conditions I'm going to show you. That gives you the green light to call it binomial so that you can do the math that I'm going to show you. If at least one of those 4 conditions is not fulfilled, you have no right to call it binomial, and therefore you will have no right to do the math I'm going to show you, okay? So the very first thing we're going to test if this follows a binomial. So what does that mean? You want the number of trials, which means number of light bulbs you're going to test, to be fixed ahead of time. So we decided to pick, why did I write 30? I meant to write 20. Oh, I know why. Okay, I'll show you later. So you, as the quality control expert, decided to pick 20 ahead of time. So there is a difference between test light bulbs until you find the first non-defective. Well, you might end up testing only 1, you may end up testing 100. So that wouldn't be fulfilling this condition. The number of light bulbs that you are going to test has to be fixed ahead of time. You already knew you're going to test 20 of them. There is a difference between saying, please test 20 light bulbs, and please test light bulbs until you get the very first defective. See the difference? Okay. The second one, you don't know how long it's going to take you. You might get the first defective on the very first trial. You might get it on the 30th trial. You don't know. But this is different. You're going to take 20 light bulbs and you're going to test them. Okay? So, is the number of light bulbs fixed ahead of time? The answer is yes. We picked 20. I gave you the answer in blue. This is the thing in black that you have to answer. And the answers are in blue. Okay? The second condition. Do you have 2 outcomes, 2 outputs? You can't have more than 2 outputs. It's a binary. Well, these light bulbs are either defective or non-defective. There is no happy medium. There is no like, oh, I'm defective today, and depending on the mood, now I am not defective. No, you're either defective or non-defective. You're either on or off. You either pass some exam or you don't pass. A woman is either delivers a baby or has not delivered the baby. There is no in between. So it is a binary. It has to be a binary. We know it is a binary because the light bulbs have only 2 options, to be defective or non-defective. Okay, so 2 conditions are fulfilled. Let's go to the third one. The probability of success, which means non-defective, the chance of having a non-defective / defective is fixed. Well, we knew you found 4 out of 20 to be defective. That's 20%. We call it Q. Q is just the probability of failure in our case, the probability of getting a defective light bulbs, it's 20%. The probability of success, which means non-defective, we call it P. This P has nothing to do with the word probability of. You know how we write like this? Probability of something happens. This P is just a number between 0 and 1. It tells you the probability of success and the probability of failure. It has to be fixed. It cannot change from one moment to another moment. For example, you might say, well, what do you mean by change? So let's say I give you a deck of cards. What's the probability of pulling a heart? Well, it's 13 out of 52, which is 25%. Make sense? So that 25% never changes. No matter what deck of cards you use, the probability of pulling a card that's random and happens to be a heart, is 13, because there are 13 hearts, divided by the total, the sample space, 52. So that's 25%. It doesn't matter if you're in China or Argentina. It doesn't matter if it is morning or afternoon. It doesn't matter what deck of cards you use. It's always 25%. That doesn't change. But how does that change sometimes? Here is the situation. I give you a deck of cards, and I say, okay, pull a card. What's the chance of getting a heart? You say 25%. I say, okay, once you pull the card, you put it on the side. You don't put it back in the deck. Now, what's the probability of getting a heart again? See, now it changes. Now you only have 51 cards. And you may have pulled the heart already. You may not necessarily have pulled the hearts. The probability changes. Why? Because when you pull the first card, you did not put it back in the deck. Okay? So we are saying that the probability of non-defective light bulbs and the probability of defective light bulbs is 80% and 20% respectively. Okay, that doesn't change. It should not change on you. The last one is the event, which means testing light bulbs are independent. So if I break the 17th one, remember I'm going to test 20. If I break the 17th one, or I test the 17th one, and I find out that it is working or not working, it doesn't matter. Does that have any bearing on the 18th one or the 19th one? You see, testing those light bulbs are completely independent. Testing a light bulb on the very first light bulb has nothing to do with testing the 19th one. Let's say you want to test 20, and the very first 10 were defective. The probability that the 11th one is defective or non-defective is still 50%, right? It doesn't change. It might be defective. It may not be defective, regardless of how it turned out for the previous ones. So those events are independent. And here's my answer. We assume that a light bulb is defective, has no influence or no bearing on the condition of the next one or the previous one, okay? So these are the 4 conditions you have to check. Once the conditions are checked, then you can answer any question. What's the probability that 3 of them are defective? What's the probability that 19 out of 20 are non-defective? What's the probability that you pull 20 at random and all of them are good, right? We can answer all of those questions. But we're going to need one more thing, which is the idea of combinations, okay? This is going to help me find these numbers here. Okay? So that's all I'm going to need. What is a combination? Intuitively, you already know what it is. So if I say to you, I have 5 students, in how many ways can I pick 1 out of 5, right? 5 choose 1. In how many ways can I pick 1 student out of 5? Oh, there are 5 ways, right? So let's say these people are A, B, C, D, E. I can pick this one, I can pick this one, I can pick this one, I can pick this one. There are 5 ways. Make sense? Now, a little harder question. In how many ways can I pick 4 out of 5? Well, I can pick this 4. I can pick this 4. I can pick this 2 and 2, which is 4. See how ugly it is? But there is a way around it. To choose 1 out of 5 is the same thing as choosing 4 out of 5. Why? I'll show you. If I choose this 1 out of 5, am I not choosing 4? Let's say I have 5 students, and I say, hey, go up to the board. Go up to the board, please. Am I not saying, hey, you 4, please remain seated? So to choose 1 out of 5 is the same thing as choosing 4 out of 5. This was easy to find. This is hard, but you get it for free. So let's say I choose this guy out of 5, this C. Choose 1 out of 5. Okay, I can choose this or that or that or that or that. Let's say I choose C. If I choose C, it's like choosing A, B, D, E. Right? If I say, C, please go up to the board, it is the same thing as saying A, B, D, E, please remain seated. Right? So even though it is really hard to figure out all sorts of 4 ways, 5 ways to get 4 out of 5, there is 1 here, there is 1 here, there is this 3 and this 1. You see, I can easily get lost. All you have to do is choose 1 out of 5, which you can do very easily, and you get 4 out of 5 for free. Let's do another one. In how many ways can you choose 2 out of 5? Well, I could choose, I'm going to stick with A, okay? Stick with A for now. I'm going to choose these 2. 1, 2, 3, 4. I'm done with A. Stick with B. We're at 4 right now, okay? Stick with B, okay? 5, 6, 7. I'm done with B. Move to C. We are at 7, remember. 8, 9. Done with C. 10. There are 10 ways. It wasn't hard. It was a little harder than this one, but it wasn't hard. You could do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if I say to you, choose 3 out of 5, it's easy to get lost. You could say 1, 2, 3. Now I'm already lost, right? But because I knew how to choose 2 out of 5, I already know how to choose 3 out of 5. If I choose these 2 out of 5, it's like choosing these 3 out of 5. If I choose these 2 out of 5, it's like choosing these 3 out of 5. Make sense? So if you know this, you know that's for free. Here is one that is really easy. How do you choose 5 out of 5? Well, there is only one way. This is it, right? That's one way. Okay. Which means, by the way, using the same trick I used here and I used here, how do you choose 0 out of 5? One way. I know it doesn't make sense to choose 0 out of 5, but because what's the difference between 1? If you choose 1, it's like choosing 4, because total is 5. If you choose 2, it's like choosing 3. If you choose 5, it's like choosing 0. There is one way to choose nobody out of 5. If that confuses you, since you know this, you get that for free. Now, having said all of this, you never have to do it by hand. So imagine I have more. Whatever, right? That's a nightmare. You never want to do this by hand, okay? But I'm just trying to show you the idea of symmetry. That's why I did this, to show you the idea of symmetry. You never have to do this by hand. In fact, there are 2 ways to do it, and you never have to think. One is to use a formula. Choose R out of N. Choose R out of N. On the calculator, it looks like this. In some books, it looks like this. All it means is N factorial over R factorial and N minus R factorial. What is factorial? Factorial is a function like this. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3, you got the point, times 2 times 1, okay? And I'll talk a little more about that maybe in next video. There are some really neat things about factorials. So if I want to do, if I want to do this one, 5 choose 1, 5 choose 1, right? Or 5 choose 1. You do 5 factorial, n goes here, 5 factorial, over r is 1, right? 1 factorial, and then 5 minus 1, which is 4, 4 factorial. Now 5 factorial is 5 times 4 times 3 times 2 times 1. 1 factorial is just 1. You always stop at 1, okay? And 4 factorial is 4 times 3 times 2 times 1. Notice these cancel. So you end up with 5, which is exactly what we got. Now, choose 4 out of 5. Even mathematically, it's going to make sense to you. Choose 4 out of 5. So 5 factorial goes here, r goes here, and 5 minus 4 is 1. But without even doing the math, isn't this the same thing as this? 1 factorial, 4 factorial, 4 factorial, 1 factorial. What do you care, right? I can commute them. I can flip-flop them. So we knew the answer is going to be 5. And if you do this on this, you're going to get 10. I'll do this very quickly, okay? You're going to get 5 factorial over 2 factorial and then 5 minus 2, which is 3 factorial. So this is 5 times 4 times 3 times 2 times 1. And 2 factorial is just 2 times 1. And 3 factorial is 3 times 2 times 1. And 3, 2, 1, 3, 2, 1 cancel. This is 2. This is 20. 20 over 2 is 10. Done. And if you do that, you get that for free as well. Are you with me? So if you don't want to, if the letters here is too many, let's say I have 100 students, in how many ways can I pick 17 out of 100? You never want to do it the way I did it in red. You either want to do it this way, or better yet, use your calculator, which is really cool. So let me erase this. Calculator is easy. You go to your home screen, make sure it's empty. It's empty, and you type. Let's say I want to do this one. Okay. You type 5 first. This is the calculator. This is how you use it. You write 5 C4, right? We want to do which one? We want to do this one, right? 5 C4. You type 5 first. Press 5. Then go on the home screen. Press 5 on the home screen. Make sure it's empty. Home screen is empty. Just type 5. And then you go to math, and math is right underneath the green button alpha. Click on math, and once you click on math, go to the right. I'm going to do it right next to myself here. Yeah, go to, when you click on math, you're going to see a menu of like 4 things. Go to probability, so it's on the very far right. Go to PRB, probability, and scroll down to number 3. And what you're going to see is, you're going to see this letter, this thing. Well, you already put 5, didn't you? So when you get to math, when you get to probability, and you get to number 3, click on it, and it's going to do this for you. It's going to enter C for you. And then just type R, which is, we said 4, and enter. And that should give you the answer, okay? Now, why is this helpful? Because it's way much faster than this. So imagine I have something like this. Imagine I have 1,000, choose 531. First of all, it is almost impossible to do it with letters that I showed you earlier. So that's just forget it, okay? This will take you a long time. You will get it, but it'll take you a long time. But if you just type, go to your home screen, write 1,000, then go to math, then go to PRB, then click on number 3, and that's going to insert C for you, and then just write 531, enter, and you will know how many ways you can combine 531 out of 1,000. In how many ways can I have 531 friends out of 1,000? Okay, it's a huge number. Okay. All right, now that I did that, now we can answer the questions about the light bulbs. You can answer any question you want. We know it is a binomial distribution because it fulfilled the 4 conditions. And we know how to play with combinations. So I'm going to end with some answers, and then I'll give you little assignments. So what does this mean? This means what's the probability x equals 1? What does x stand for? X stands for the number of non-defective light bulbs. So x equals 1 means 1 is non-defective, right? Isn't that what I said? Yeah. 1 is non-defective, and 19 of them are bad. Makes sense? So clearly, if one of them is good, you take the probability of 0.8, isn't that the probability of success? And you raise it to 1 power because only one of them is good. And the remaining 19 are bad. So the probability of failure was Q. So it's 0.2 to the power of 19. Don't worry about this for now. Okay? So 1 success, 19 failures. You don't multiply 19 by 0.2. You raise 0.2 to the 19th power. Because 19 failure means failure and failure and failure. And remember, I said with and, you do times. 0.2 times 0.2 times 0.2, 19 times. So it's 0.2 to the power of 19. Now, why do I write this number? 1 success, 19 failure. Why on earth am I writing these numbers here? Well, you have 1 success and 19 failures, but in how many ways could that happen? You could have 1 success followed by 19 failures. You could have 1 failure, 1 success, and then 18 failures. You could have failure, 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 3 failures, and then success, and then 16 failures. There are many ways that could happen. Choose 1 out of 20. In how many ways can I have 1 success and 19 failures? There are 20 ways. If you compute this using either this method, or even the method I did here, imagine you have 20 letters. In how many ways can you pick 1? Well, there are 20 ways, right? So this is just that. So when I multiplied, I got basically 0. I got like 0.0000. It's almost the probability. If you have, here's what it means. If 4 of them are defective and 16 of them are good out of 20, which is 80% are good and 20% are bad, what's the chance that only one of them is good? You know it's going to be very, very, very slim, small. Well, I got almost 0. It's not 0, by the way. But it is almost 0. I got 0 point, like, I don't know, gazillion zeros, and then some 1, 2, 3 or something. So it's approximately 0. Now, if you don't like to do it this way, you can use the graphing calculator. And what you want is what we call binomial PDF. So if you don't want to do this by hand, and it can get ugly, you can also use a calculator. Binomial or binomial PDF. The PDF stands for probability density function. All you need are 3 letters. N is the number of trials, P is the probability of success, and X is whatever you're interested in. So in our case, N is 20, probability of success is 0.8, and we are caring about 1 non-defective, right? 1 non-defective. If you just enter this, you'll get the same answer you got here. Now, how do you get to here? So like, let's say you are here already, you know what to write. But how do you get to here? Here's how you do it. You go to your TI 83 or 84, whatever. Click on second function in blue, top left. Second vars, which means distribution. I could have just said, please click on distribution, but you're not going to see it. But if you click on second vars, you'll see the word distribution in blue. Once you click on distribution, you scroll down to letter A. That's going to give you the binomial PDF, not CDF. There is another one that says CDF. That we don't care about CDF. It's PDF. And it's going to give you a table like this. It's going to give you binomial PDF, but it's not going to look this way. It's going to look like that. Number of trials, you write 20. P, 0.8. X, I'm interested in 1 non-defective. And it says paste, click on it, and you're going to get the answer. Okay? So how about, what's the chance P of X equals 19? What's the probability that 19 of them are good? 19 of non-defective light bulbs and only 1 defective. Well, it's 20 choose 19. And then the probability of success, this is not this P. This is just the probability, and this is the probability of success. We have 0.8 to the power of 19 good ones and 0.2 to the power of 1 bad one. Now, 20 choose 19, you could definitely use the calculator or do this, but you already know the answer through the tricks that I showed you. If you know how to choose 1 out of 20, you already know how to choose 19 out of 20. So it's the same answer, 20. Okay? And I got about 5.7% or 5.764%. If you don't like to do this math, you go to second vars distribution A, number of trials 20, probability of success 0.8, and X equals, you change this to 19, click on paste, and you're going to get this answer. One more. What's the chance that 16 of them are good? Imagine you have those 20 light bulbs, you tested them, and you already know your success rate is 80% and your failure rate is 20%. What's the chance that if you pick any 16 whatsoever, any 20, 16 of them will be good? What's that probability? Okay, well, it's 20 choose 16. It's always 20. Choose 1, choose 19, choose 16. P to the power of 16, there are 16 successes, 16 non-defective, and the probability of failure to the power of 4, because there are 4 defective. 0.8 to the power of 16, 0.2 to the power of 4. Now, 20 choose 16, you don't want to put 20 letters here and start choosing 16. You'll take another 3 years to get there. You can do 20 choose 16, which is 20 factorial, 16 factorial, 4 factorial. You'll get the answer. Or just do what I did here. And I got 4,845 ways to choose 16 out of 20. There are 4,845 ways to choose any 16 students out of 20 in a classroom. See how many? Okay, so if I multiply this by that, I got that. Or you could do this, 20.8, 16, paste. I got about 20%, 21.82% or 22%. All right, so I just did 3 quick questions. I tested the conditions. Make sure you test the conditions. 4 of them, 1, 2, 3, 4. If they are good, then you can answer questions. And they get a lot more interesting, but I don't want to overwhelm you today. I'm going to conclude with a problem for you and then a brain teaser, okay? So I would like you to go online and pick an airline of your choice. JetBlue, Southwest, Delta, I don't care. Pick any airline of your choice. Remember my 3 parameters. The only thing we need to know after you check the conditions are N, number of trials, P, probability of success, which means if you know P, you know Q, right? If I know 0.8, I already know 0.2. And X, whatever the question I'm going to ask you, whether it is 1 or 19 or 16. So you just need N, P, X, okay? So I would like you to pick an airline of your choice. Maybe the one you like, or maybe the one you are curious about. And just Google what's their success rate. Success means they are punctual, you know they are always late. So what's their success rates? That's your P. which means you already know their failure rates, not leaving on time. If a company, by the way, they collect that information every time their flight takes off on time or doesn't take off on time. They collect that information because they want to improve, hopefully. And that information is public. You can find out what is their success rate, which means it's not hard for you to find P and Q. Probability of success, probability of failure. I'm giving you N. I'm gonna ask you, we're gonna test the next 30 flights, maybe next week, right? Before they fly, we're gonna say, hey, based on 30 flights, let me give you some probabilities. Isn't that what I did here? Based on 20 light bulbs, here are some probabilities that I computed. That's what I want you to do. So, I'm giving you N, right? You're gonna find P or Q, and that's all you need. So, after you do that, find out what their success failure rates, which means find P and find Q, right? If you know P, you know Q. Then check the four, I'm reminding you, check the four conditions. This is going to be a binomial, okay? But I want you to check the four conditions and write in detail. Don't just say two outcomes, event independence, rates don't change. I want you to write not just this stuff in blue, but also the stuff in black. Okay, so check the conditions. If it fulfills the binomial distribution, check the four conditions to decide if the random variable that measures how timely the flight R follows. Oh, I made a mistake. A binomial, not normal. We haven't done normal. A binomial distribution. If those check, then answer these 6 questions. Okay? What's the probability that no flight leaves on time out of 30, right? 1 flight leaves on time, 2 flights leave on time. They're going to be very small, obviously, right? The probabilities are going to be extremely small. What's the chance that 18 of them leave on time? What's the chance that 19 leave on time? I'm going to change, if you don't mind, I'm going to change 30 flights into 20 flights. Keep it simple for you. Okay? And then what's the probability that all of them will leave on time based on the success rate that you found earlier? Okay? It really should not take you more than 20 minutes. And I say 20 because find the airline and find their success rates and all that, that's going to take 5-10 minutes. But those, you just do what I did here, okay? And you could just use the calculator. All right, so brain teaser. How can you multiply 81 by 9 and get 801? Now, just so you know, 81 times 9 is 729. It's not 801. But how do you make it work, okay? Don't say, I get 729 and I added 70 whatever to get a... No, you can't do that. Again, it's a brain teaser. So have fun with this one. It's really cute. Now, the answer to the previous question, I said you have what did I say? 2 parents and 2 sons, and they have 3 fish to split. It's basically, and many of you got it. So you have a grandfather. Okay, this is the grandfather. Then you have the father. Make it smaller. And then you have the son. Now, you actually only have 3 people because the father is a son as well. Is the son of this guy, but a father of that guy. So you have 2 sons. This is a son for sure. This father is also a son of the grandfather. So you have 2 sons. You have 2 sons. How about fathers? Well, you have this one. That's a father of this one. And that is a father of this one. So this guy plays 2 roles. Dual role. This person is a father and a son. So I tricked you. So basically there are only 3 people and there are 3 fish. So each one of them takes 1 fish. It's over. Goodbye. All right. Have fun. Take care. Bye-bye.